Okay, let's talk about equivalence and solving for x. I have an equation like this, and whenever I'm solving for x, I do a set of operations on it that gets me to what I believe x is. I isolate x on one side and I keep a number on the other side. But in order to do that, I need to make equivalent operations. And what that means is that I do an operation, or I do a series of algebraic manipulations that keeps x true for every step. So if I were to switch this to 3x plus 3 is equal to minus x is equal to 9. I've done an equivalent operation. X will satisfy this equation as well. It will satisfy this equation. If x would be 2, it would I don't know if x is 2 in this case, but any x that gets you the 9 right here will also get you the 9 right there. So they're equivalent. I've done an equivalent operation. If I keep going down and let's say I want to take 3 from this side, from both sides, I can do that. I can subtract 3 from both sides. I can say, okay, well, I'll just take 3, and then we are left with 3x minus x is equal to, well then, 9 minus 3 is 6. And this will be true for any x that is 6 for over here. As in, if x is a certain thing, let's say x is 3. I believe it's 3 right here. 3 times 3 is 9. Minus 3 is equal to 6. Then that means 3, if I put 3 right here for x, this should be equal to 9. 3 times 3 is 9. Plus 3 is 12. Minus 3 is 9 again. So it is true. What I've done was an equivalent operation by subtracting 3 from both sides. And I can keep doing this. But again, these equivalent operations means that the x that works for that equation has to also work for these equations. They have to be equivalent. So anything you do on one side, you have to do on the other side. If you divide, multiply by non-zeros, you have to do on the other side. And you might say, well, what about what are non-equivalent operations? Well, things that only happen to one side. Let's say I go x is equal to 2, right? If x is equal to 2, then that means that when x is equal to 2, x is equal to 2. But if I add x to one side, then this no longer is an equivalent statement, because x is equal to 2 on this side. X is equal to 2 on this equation, but now I've added 1 to one side, and now it's still equal to 2. That can't happen anymore. If x is equal to 2, 2 plus 1 will equal 2. I would have to add 1 to both sides in order to make it like that. Or whenever we have equations like 5x is equal to 6x. This, you might be tempted just to like divide both sides by x, but then you'll get x divided by is 5, and then this will be 6, and 5 equal to 6 is clearly not true. So you have to be careful because this necessarily doesn't mean that this isn't true, because what you could have is that x could be equal to 0. X could be equal to 0. So what you would want to do instead, to be completely sure, instead of dividing, you would subtract 5x from both sides, and this would become 0, and this would become 1x, which is just x, and x would just be equal to 0. So yeah, whenever you're doing something like this, where it's just x equals something, you need to be careful with the multiplication and divisions by 0, and because then 0 divided by any number divided by 0 is undefined. And you need to make sure you're doing operations on both sides of the equation, and make sure they're equivalent operations. Okay, it's cool.